Good afternoon everyone. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to the Maha Marathon session of Computer Science. Today we are going to practice the very interesting subject, very important subject, and I think most of the favorite subject, that is computer networks. So please do join the session quickly. I am Satya, waiting for you all to join the session. Kaushalya, Chandan, Madhav Maheshwari, Sambhav Jain, Kirti Kumar, good afternoon. Mayank, Pooja, good afternoon. Quick, I am waiting for you all to join the session. Also, those who have joined, please mark your presence. Guys, could you please confirm, am I visible and audible to everyone clearly? Quickly share it, guys. Quickly share as much as possible. Bring all your friends for this very useful session. Keshish, Sunil, Muskan Priyadarsini, Roshini, Kritika Madan, good afternoon. Okay, great. So, now our BYJU'S Exam Prep has become a complete solution for all GATE kind of exams, and exclusively if I talk about GATE, if you want to prepare for 2 years of time, you can prepare with BYJU'S Exam Prep. If you want to prepare for short term, yes, we are with you. And if you are looking for only practice questions, still we are with you with the rank up kind of course. So guys, do share this BYJU'S Exam Prep. Do recommend this BYJU'S Exam Prep courses for all your friends. And yep, subscribe our BYJU'S Exam Prep channel. Yes, guys, I request everybody to please invite your friends by sharing through WhatsApp, Telegram, Facebook, Twitter, Insta, everywhere, wherever you can, because it should be beneficiary for as many as possible, right? So this is brief about me. I am Satya with all these credentials, and this Maha Marathon session for all the branches of mechanical, civil, ECE, electrical and computer science and engineering has started on 3rd Jan and successfully going in all the branches. I hope all the students are getting benefit out of it, and I hope these sessions are becoming very useful for you, right? So please do comment, guys. Are you people really enjoying these sessions? Are these sessions are helpful to you? Yes. Nisha, Siddhant, Umesh, Noob Studios, good afternoon. Yep. So shall we start? Yes. I want everybody to comment, to give your answers in the chat box. Are we ready? Is it good to go? Are you prepared with? Jelinam, all the GATE syllabus of computer networks through questions. We will cover Prakash, Siddhant, okay, chalo. So guys, the very regular question to you, in computer networks, if I ask you to rate yourself out of 5, if I ask you to rate yourself, so how do you rate? 5 means you are perfect in computer networks. So how do you rate yourself? Yep. Everybody give your responses in the chat box. 4, 3.5, 4, 2, okay. 4, 4.5, great. Nisha Yadav, 4. Kirti Kumar, 2.5, 2 out of 5, 2 by 5. 3, 4, 4. Oh, great, great. Unnati, don't worry. Nishat, 4.9. Great. Life is full of surprises. Theory is good, but problem practicing very less. Okay, let us practice now. Chandana, computer networks is my favorite. Even my favorite, one of my favorite subjects also. Chalo. So guys, let me shoot the very first question of today's Maha Marathon session of computer networks. So the first question is on your screen. Why question is not coming? Yep. Here is the first question. For an IPv4 datagram, consider the following information. MF bit 1, HLEN 5, total length 300, fragment offset 100. Find the position of the datagram, sequence numbers of the first and last bytes of the payload field. Yes. For the very first question, give your answers, everybody. We are given with some parameters information of IPv4 datagram. By using them, you should find the position of the datagram, sequence numbers of first and last bytes of payload field. Yep. Lavish Tripathi, option D, okay. What about others? Sobhagya Nayak, option D, yes. Guys, please use question number. Please use question number for giving your answers. Okay, so firstly, given total length. What is total length? Total length is header length plus payload length. Right? Okay. Now, HLEN value is given as 5. 5 means what is header length? 5 multiplied by 4, that is 20 bytes is the header length, which is the minimum header length. Okay. And payload length we have to find out. Total length is given as 300 bytes. So, if this is X, what would be X? 280 bytes. So, we have 280 bytes of payload to sequence. Now, the fragment offset gives you the starting position, the starting address of it. But this is not the exact value. How we do? Fragment offset is always multiplied by 8. So 100 into 8 gives the starting position of this particular payload. So if it starts with 800, and we have 280 bytes of payload to give the numbering, so where it goes till 1079. And this fragment position, how we find? With MF. If MF is equal to 0, that indicates there are no more fragments. That means it is the last fragment. But we are given with MF as 1. So it can be first fragment, it can be middle fragment also. So let us see. If it is first fragment and the sequence numbers are not matching, so definitely it is not, and it is not last fragment. And it can be middle fragment, the sequence numbers are not matching, so definitely it is a middle fragment, and the sequence numbers of starting is 800, last is 1079. Right? Great. I appreciate everybody who have given the right answer. Very good. Next question. A router with a maximum transmission unit of 1620 bytes received a datagram of 5000 bytes with an IP header of length 20 bytes. What would be the total length of the last fragment? Yes. A router with MTU of 1620 bytes received a datagram of 5000 bytes with an IP header of length 20 bytes. What is the length of last fragment in bytes? $120, okay, $140, okay, $139. All right. We have a router. It has received a packet of size 5000 bytes. But this router can transmit only 1620 bytes at a time. And this 1620 bytes is with header or without header? With header. So MTU is 1620 bytes. In this 1620 will have 20 bytes of header, definitely. So how much payload will be there? In every packet 1600 bytes of payload will be there. So what it do? It will divide this 5000 bytes into 1600 for first packet, 1600 for the second packet, 1600 for the third packet. How much is left? 16, 16, 16, 48. So how much is left? 200 bytes is left. So for the last packet, 200 bytes of payload is there, and what we want, not payload length, we want total length. So what is total length? Payload length plus header length. Payload length is 200 plus header length is 20, so 220 bytes. So what is the answer? 220 bytes. So whoever have given 220, please award yourself mark. The others, please update your scorecard accordingly. Okay. So I can see someone has rated themselves 4.9, 4.5, but I can see they giving wrong answers. So guys, it is appreciated if you are really confident, but don't make it overconfidence. Okay? Chalo. I hope you take it positive. Noob Studios, no yaar. 5000 bytes received from the transport layer. So whatever is received, that is what taken as payload by the network layer. No. Now, next question. What is the order of socket functions that will be called by TCP server for establishing the TCP connection with TCP client? It won't be 4980. How 20 bytes header would be there in the transport layer? That is the header at network layer. We shouldn't subtract. So what is your answer for question number 3? It is previous gate question. For establishing the TCP connection, what is the order? Socket, bind, listen, accept. So you will have this client server communication with TCP system calls. Please refer to that. If you miss, client server will be there. So socket will allocate a port, then bind will be for, let's say, requesting the connection. Listen is what received by the server, and then server will respond with accept signal. Okay, Nishu, right. Shalom. The next question. Consider congestion control in TCP. Slow start phase, congestion avoidance phase, congestion detection phase. Match properly. Very easy question. A direct question. And don't think like gate means all will be very difficult questions. All questions would be beyond your level. No, that is just a myth. It's a wrong perception. In the gate, there will be easy questions also, direct questions also. Maybe the percentage of such questions would be less. But you will definitely get some easy questions. But guys, in gate, you don't get full forms, you don't get the inventor names, you don't get invention years and all. So don't waste time in remembering those full forms or inventors or history. Okay? Guys, use question number for giving your answers. Guys, why day to day I can see there is a drop in the students. कि keep liking the session, keep sharing the session, guys. When you really say these sessions are becoming useful, then definitely you should do that. You should invite your friends for these sessions. Okay. So all are with option A. It's a direct question. Slow start phase, the window size increases additively. Is it? Yes or no? No. It increases exponentially. Where the window size increases additively in the avoidance phase. So, yeah. And in the detection phase, window size keep decreasing. So, it is 1B, 2C, 3A, of course. Next question. The initial window size and threshold at the beginning of slow start phase in TCP congestion control algorithm are 4 MSS and 16 MSS. Assume timeout occurs after 5th transmission. What would be the size of congestion window after 8th transmission? Jainam, once the timeout occurs or congestion occurs, then congestion detection phase, multiplicative decrease phase will start. There onwards, the window size keep decreasing. Like if it is, let's say, at 30, in the next transmission, straight away it goes to 15. Then straight away it goes to 7, then to 3, and it goes till 1 or till the slow start phase size. Again it loops. Okay. Chalo. What is your answer for this question number 5? Firstly, in the first transmission, the window size is 4 MSS. Right? In the next attempt, in the next transmission, the window size increases exponentially. So it becomes what? Yeah, for 1 RTT it becomes what? In the second transmission it becomes what? Eight MSS. In the third, it becomes 16 MSS. Threshold reached. It reached the threshold. Okay. So, during the slow start phase, when threshold is reached, then what we do? Timeout occurs during 5th transmission. Additive increase phase will start when threshold is reached. So here, how much it will be? The window size increases by 1 or 4 in the additive increase. It was 2 square, then in the next transmission it becomes 2 cube. In the additive increase, will it be plus 1 or plus 4? I want that. One or 4. Regularly when you were learning, you will be adding 1. Why? Because the slow start phase initial size is 1 MSS. 2 power 0, but here what is the initial size of slow start? 4 MSS. So it should be 4, guys, and during 5th transmission it would be 24 MSS. Here timeout occurs. So whenever timeout occurs, slow start phase again resume by making the threshold half. So threshold will be now 16 divided by 2, 8 MSS. Now in the 6th transmission, again slow start phase will start. Now the window size would be 4 MSS. In the 7th transmission, it would be 8 MSS. Now threshold reached. So when threshold reaches, additive increase phase will start. This will add plus 4. So this would be 12 MSS. During at the end of the 8th transmission, it would be what? 12 MSS. So 12 should be the correct answer. Madhav Maheshwari, that is what I am telling. When the initial size is 1, then you will add 1. Otherwise, you will add whatever the initial size. Ankit sir might have added because he might have started with 1 MSS, the initial size of CWND. Okay. Next question. Consider the TCP header format. Okay, and match these 6 flags with respective purpose of these flags. In the TCP header we have 6 flags, right? Kirti, the timeout is given in the question. It's not I have taken. At the end of 5th transmission, timeout occurred. So when the time is out, SS phase resume with the half threshold. Guys, however, whether you add 1 MSS or 4 MSS, it doesn't make any difference, because during the timeout, once timeout occurs, you start again with 4 MSS, right? Okay, maybe you could say the answer would be 9 MSS if so, but the answer would be 12 only. Okay, 6th question, A, and somebody is giving B. First, which is used for the termination of the connection? FIN, finalize. And with this you can understand sending urgent data URG, and which is used for establishing the connection SYN, reset the connection RST. Only one is left, push. Now 1B, 2E, 3A, 4C and 5D. Option A. Next question. If a selected CSMA CD network takes half of the time than usual transmission delay and 4 times that of usual propagation delay, then the relation between them can be expressed as, let T1 and T2 be the resultant transmission and propagation delays. Yes, right, Nishu. If a selected CSMA CD network takes half of the time than usual TD and 4 times that of usual PD, then the relation between them can be expressed as, let T1 and T2 be the resultant transmission and propagation delays. Anvesh Patra says option C. Okay. Mathav Maheshwari C. Alright. Noob Studios A. Guys, after this question, until you share and invite your friends for this session, I don't go ahead, I don't proceed. So please do share the session quickly. C, A. I think the tie is between A and C. In CSMA CD network, transmission delay will be two times of propagation delay. Okay. Yes, of course we can take greater than or equal to, but here ideally you can say equal to. Now it is given T1 is what the transmission delay, T2 is what propagation delay, and regularly if it is taking T time, but here it is taking half of the time. So T1 is equal to T divided by 2, and what is the propagation delay? 4 times that of it. So what is the relation that you can establish between them? Relation that you can establish between them. From this I can say T is equal to 2T1. So substitute this T there. So T2 is equal to 4 into 2T1. That is T2 is equal to 8T1. Wait. Wait. Just give me a moment. Yeah, this I have not taken, sorry. So here T by 2 is equal to 2 into 4T. This is what? T1. So T1 is equal to 2 into T2. T1 is what? T by 2, that is equal to 2 into 4T. So yes, it would be 16 T2, right? Sorry, 16 T2, correct guys. Two 2s are 4, 4 4s are 16. T1 will be equal to 16 into T2. T1 is equal to 2 into 4 T2, 16 T2. Yes, yes, you people are correct. Next, consider a network that uses CSMA by CD if two stations X and Y are attempting transmissions in such a way that X won the first back-off race and Y won the second back-off race. Let the probabilities for winning in the next attempt by X and Y be P1 and P2 respectively. Then how you can establish the relation? Yes, please. What is the answer for question number 8? We have two stations X and Y. So let's say the first transmission X and Y tried to send their packet. Let's say this is packet P1, this is packet PA. Collision occur. So what they do, they will pick a value because it is the very first collision for their packet. They will pick a value from 0 to 1. So the probabilities are 0 0, 0 1, 1 0, 1 1. 0 means the station will not wait. 1 means the station will wait for one packet transmission, so that collision will not occur for the retransmission. Here it is given X won the first back-off race. X won the first back-off race. That means either wait. Here 0 0 means again collision occurred. 1 1 means also collision occurred. 0 1 means X is not waiting, Y will wait. 1 0 means X will wait, Y will not wait. So we can say this is what they have chosen. X chosen 0, Y chosen 1. So X won the first back off race. That means X successfully transmitted P1. Now X will try to attempt P2 transmission, but Y still try to send PA. So P2 and PA here collided. Now for this particular packet, how many times collision occurred? Only one time. And for PA, it is the second collision. So Y will choose a value from 0, 1, 2, 3. X will choose a value from 0 and 1. So the probabilities are 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3. Again, given Y won the second back off race, that means this is the option they have taken. X decided to wait, Y is not waiting. Done. So X has sent P1 successfully, Y has sent PA successfully. Now the third transmission. X will attempt its second packet, Y will attempt its second packet PB. Collision occurred. Now for P2, how many times collision occurred so far? 2 times. 2 times, right? Because already here occurred. So X will choose a value from 0 to 2 square minus 1, that is 0 to 3. Y for PB, how many times collision occurred? This is the first collision. So A will choose, Y will choose a value from 0 to 2 power 1 minus 1, that is 0 to 1. So what are the probabilities? X may choose 0, Y may choose 0, X may choose 1, Y may choose 0, 2 0, 3 0, 0 1, 1 1, 2 1, 3 1. Now the probabilities for winning the next attempt by X be P1, Y be P2. So here Y has chosen 0 or Y has chosen a less value than X, means Y win the back off race. Y win the back off race. So out of 8, let us calculate. Both has chosen 0 means collision. Both has chosen 1 means collision. Array. Why I am wait 0 0 1 0 2 0 3 0 0 1 1 1. So this one I have to pick up. Yep. So both has chosen 1 means this is also collision. In the other, X chosen 0, Y chosen 1. This means X win the first back off race. X win the race. And the others, if you see, Y value is lesser than X value. That means here 3, here 2. So what is the probability for Y winning the race out of 8? 5. So P2 is 5 divided by 8. And what is the probability for X? What is the probability for X? only one transmission, only one probability out of 8, and probability of collision is 2 by 8. Okay, so now what is the relation between P1 and P2? P2 equals to 5 into P1, right? Option C. Anvesha Patra in the third attempt, why will not choose 0, 1, 2, 3? Because why choose 0, 1, 2, 3? For that particular packet, only one collision occurred. So we have to choose a number from 0 to 2 raised to I minus 1, where that I is number of collisions occurred for the respective packet, for the current packet. Okay? Next question. In Ethernet network, the actual data to be sent in a packet is 30 bytes. Then the sent packet includes dash bytes of padding. In an Ethernet network, if the actual data to be sent in a packet is 30 bytes, then the sent packet includes dash bytes of padding. Muskan Priyadarshini, which one? Question number 8 you want me to explain again? Anyone want me to explain question number 8? Okay, so all are giving option C, option C. All right, we know in Ethernet the minimum frame length should be 64 bytes and maximum length should be 1518 bytes. This is the frame length. But in this 64 bytes or in any frame, frame means what will be there? Payload, header. Both together it is a frame. And what is the Ethernet header length? What is the Ethernet header length? 16 bytes. 18 bytes, sorry. You will have 6 bytes of source address, 6 bytes of destination address, 2 bytes of length field and 4 bytes of this CRC, right? Source address, destination address, length field and CRC. So out of 64, 18 bytes gone for header. So how much payload must be there? Minimum 46 bytes payload must be there. But you have only 30 bytes of payload. So how much padding is required to make it 46? 16 bytes padding. Okay? Okay, 8th question. I think many people were asking to explain. So I don't take much time. Please listen. The BEB algorithm, binary exponential back-off algorithm, that is especially to reduce these collisions in Ethernet. What it says is, suppose you are having two stations A, B. A is having packets P1, P2, P3 to send. B is having packets P4, P5, P6. Okay? Chandana, preamble and start delimiter, they are not part of the header. That SD is for that. SD indicates from where the frame starts. Means after that SD value, we say 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 1. That is what SD value, no? So consecutive 2 ones wherever encountered, from the next bit onwards considered to be frame. So preamble and SD are not considered to be SFD, start frame delimiter, whatever you say. They are not considered to be part of the frame. Okay? Okay, here A trying to send P1, B trying to send P2. Let's say at A time, collision occurs. So whenever collision occurs, A and B come to an understanding. How? For your packet, how many times collision occurred? 1 time. For my packet, how many times collision occurred? 1 time. So we will take that I. What is I? Number of times, or let me put it in this way, number of unsuccessful attempts made for the current packet. So whichever the packet you are sending, for this packet, how many unsuccessful attempts? Yeah, that's what, header and tailor together, okay? Nishat, header, tailor together. Okay, CRC I have kept in header, but it would be the part of the tailor only. But there I mean header, tailor, apart payload. Okay, please let me explain this. Okay, now how many times P1 unsuccessful? 1. For P4, 1 time. So I is equal to 1 for A, I is equal to 1 for B. So they choose a value from 0 to 2 power I minus 1. That means 0 to 2 power 1 minus 1 means 1. So A can choose a value from 0 to 1 or B can choose a value from 0 to 1. So now possibilities are A may choose 0, B may choose 0, A 0, B 1, 1 0, 1 1. Right? You have selected 0 means here 0 1 indicates waiting time. So how long you wait to send your next packet? How long you take for retransmission? So 0 means you are not willing to wait. So B is not willing to wait, A is not willing to wait. So if both have chosen 0, that indicates collision. Similarly, both are willing to wait for 1 packet time, and after that time elapse, both again try to retransmit at the same time. So that also indicates collision. A chosen 0 means A don't wait, but B chosen 1 means B will wait for 1 packet transmission. That means A only will send. So A win the first back off race. A win the race. If A chose 1, B choose 0, B win the race. So what is the probability for A to win the race out of 4 combinations? 1. Probability of B, 1. Probability of collision out of 4, 2. Right? Here in our question, suppose A won the first back-off race. That means A sent P1. While retransmission, A successfully transmit P1. Now, A will attempt its next packet transmission, that is P2, but B still did not send P4, no? So, B now try with P4. Collision occurred. Now, what would be I for A? For this packet, how many times collision occurred or how many unsuccessful attempts are made? 1. And for P4, how many unsuccessful attempts are made by this time? 2. Already earlier we tried, we could not send. Now you tried, you could not send. So this I will be 2 for B. So they will choose a value from 0 to 2 power 1 minus 1. B choose a value from 2 power 2 minus 1. So it would be 0 to 1, 0 to 3. Any value you can choose. So what is the combination? A can choose 0, B can choose 0, 0, 1, 0, 2, 0, 3. One zero one one 1 2 1 3. Right? Now, both chosen 0, both chosen 1 means collision. A don't want to wait, but B selected to wait for 1 packet time, 2 packets time, 3 packets time. That means A win the first back-off race. A win this race. Here B win the race. And here A will wait for 1 packet time, B will wait for 2 packets time. So once A wait is over, it starts sending, still B is waiting. That means A successfully transmit no its packet. So when any station value is smaller than the other station value, that means it will win the race. So here in this, out of 8 possibilities, what is the probability of A to win the race? 5. Probability of B to win the race? 1. Probability of collision? 2. So here it becomes 1 by 4, 25%. Here it is 50%. Like this in the next attempt, it becomes 12.5%. So the probability of collision keeps reducing. That is the advantage of it. This is how it works. Okay? Right? Yeah, here of course header plus Taylor. This is header, this is Taylor. Taylor is added by only this data link layer. But payload is lagged with 16 bytes. Next question. Let the sender node A wants to send a file of size 5000 bits using a packet size of 2500 bits to station B through an intermediate node C using a channel capacity of 100 kbps with a propagation delay of 20 milliseconds between every two nodes. Then the total time to send the file is. Kritika, Muskan, those who have asked, you all understood what is that BEB algorithm? What is the answer for question number 10? Kaushalya, option B. Saksham, option B. Okay. So we have firstly file size is 5000 bits. But packet size is 2500, means it is divided into 2 packets. Firstly, that we can understand. Then A is sending data to B through an intermediate node C. Okay. So here there will be transmission delay, propagation delay. Let it be P1, T1, T2, P2. Right? Google, yes, that's why it is called as back off. The victory or the failure, back off. If you win one time and there are more chances for you only to win, and if you lose, there are more chances to keep losing. That's how the term has come, back off. And that works for only 2 stations. That's why binary. And the probability of collision exponentially decrease. That's why exponential term come. That's how it is, binary exponential back off algorithm. Okay. So here we have 2 packets. So what is the transmission delay? Packet size by bandwidth. What is bandwidth? 100 kbps. This is bits only. So it is 25 milliseconds. Okay, propagation delay is given 20 milliseconds. Now for one packet, what is the total time? T1 plus P1 plus T2 plus P2, because we are not given queuing delay and processing delay. So this is 25 plus 20 plus 25 plus 20. This is 90 milliseconds for one packet to reach B. Now the second packet, will it wait until the first packet reach B or until it leave A? Just if it leaves A, the second packet transmission gets started. So the first packet and second packet are delayed by only transmission delay, only TD, because until T1 gets transmitted, T2 wait. Later on it starts sending. So all the other times gets overlap. So for the second packet, the extra time that you have to spend is only one transmission delay, that is 25 milliseconds. So what is the total time to send 2 packets? 90 plus 25, 115 milliseconds. Yes, Madhav Maheshwari. Next question. Let the total time to send a file of size 10,000 bits from sender to receiver are through 2 intermediate nodes A and B be 360 milliseconds. Let the packet size be 2000 bits and bandwidth is 50 kbps. Assume length of each channel is 200 meters. Propagation speed is 10 kilometers per second. If each intermediate node holds a packet for T time, then T equals to dash milliseconds. Processing delay. Quickly solve it. Guys, you don't have all the day. You should be fast and accurate. Okay, I have given enough time. Only Madhav Maheshwari is responding with B. Okay, that is 10. All right. We have source S, destination D. In between we are having 2 intermediate nodes A, B. So when you are sending the data, everywhere there will be transmission delay, means the time to load the packet. Everywhere, mean between every 2 stations there will be propagation delay. So let them be T1, T2, T3, P1, P2, P3. These are what regularly incurring times. But along with this, queuing delay, processing delay also will be there. Until unless they are mentioned, we neglect them. In this question, every intermediate node holds a packet for T time. That is what processing delay. The time a packet spent at the node, with the node. So here we are having a processing delay, let's say PR1 t seconds, PR2 t seconds. Now it is given total time. How we get total time, dear friends? Total time is equal to the time for one packet, or let's say first packet, the total time from source to destination for first packet, whatever is the time, plus for the remaining packets, let n packets are there, for remaining n minus 1 packets, transmission delay, because every packet will wait until the previous packet gets transmitted. So what is the time for first packet? At source it should be loaded, it should be propagated to A. At A it would be processed, then loaded, then propagated to B. At B it is processed, loaded and propagated to destination. This is the time for one packet, complete time, right? Now we have to calculate that transmission delay, T1 or T2 or T3. What is that? Packet size by bandwidth, 2000 divided by 50 kbps. 2000 divided by 50, 2000 bits by 50 kilobits per second. So bits and bits gets cancelled. So this is 50, 40. So this is 40 milliseconds transmission delay. And what is propagation delay? Length by speed, P1, P2, P3. I hope you know the formula. What is the length given? 200 meters, speed given 10 kilometers per second. So 200 meters divided by 10 kilometers per second. So let me convert this also into okay, directly let me do. So it is 20 milliseconds, right? So now total time for one packet would be 40 plus 20 plus small t plus 40, 20, small t, 40, 20. So this is 3 4s are 12, 3 2s are 6, 180 plus 2t. This is the complete time for one packet. Now total time is given 360, that is equal to 180 plus 2t, complete time for one packet, plus remaining packets. Total file size is 10,000 bits. Packet size is 2000. So how many packets would be there? 5 packets would be there, isn't it? So number of packets would be 5. So remaining means 5 minus 1 whole into transmission delay we have calculated 40. So this is 360 is equal to 180 plus 2t plus 4 4s are 160. Now 200 minus 180. So if you expand this, 340, 360 minus 340, 20. 20 is equal to 2t That means what is T? 10 seconds. Okay? Guys, this would not be there in the PDF that I share, I think. So if anyone want, please take a snap or screenshot of it. I'll count from 10 to 1. Please take a screenshot if you want, because this would not be there in the PDF that I share. Let me count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Chalo. Next question. Oh, very easy question. I think this is PYQ. An IP datagram of size 1000 bytes arrives at a router. The router has to forward this packet on a link whose MTU is 100 bytes. Assume that the size of IP header is 20 bytes. The number of fragments that the IP datagram will be divided into for transmission is. Simple question. Even for this you shouldn't take much time, and I don't expect a wrong answer from anybody. It's a PYQ and it's very simple. 1000 bytes, 100 is the MTU. So into how many fragments this would be divided into? Quick. $1,000. I think it won't require any explanation. However, these 1000 bytes has to be forwarded such that it should add a header, 20 bytes header, that should be equal to 100 bytes, that is the MTU. So what is X? 80 bytes of payload. So out of 1000, 80 bytes of payload in every packet. First packet, second packet, like this. If you send 12, 80, 80, 80, when you contribute, it would be 960. So in the last packet there will be 40 bytes of payload with 20 bytes of header. That is MTU, maximum transmission unit. It could be even less than that, no problem. So how many packets it would make for 1000 bytes file? 13 packets. Next. A sender uses stop and wait ARQ for reliable transmission of frames. Frames are of size 1000 bytes. The transmission rate is 80 kbps. Yeah, this is also PYQ. Size of acknowledgement is 100 bytes. Transmission rate is 88 kbps of the receiver. If the one-way PD is 100 milliseconds, no frame is lost. What is the sender's throughput? Okay. Guys, keep liking and keep sharing the session. Yes, the answer is option B, no doubt, because it's a PYQ. We are sending a file from sender to receiver through a pipe like this. Sender's channel at sender, the transmission rate is 80 kbps, but for the receiver to send the acknowledgement, as he has less bandwidth, 8 kbps. That is what given, and frame size is 1000 bytes. So what is the time TD? Sender's transmission delay, let it be T1, receiver's transmission delay, let it be T2. So T1 is equal to 1000 bytes divided by transmission rate of the sender is 80 kbps. It is in bits, that is in bytes. BPS means by default bits per second. So convert that into bits. So it would be 8000 bits divided by 80 kbps. So bits and bits gets cancelled. So it is 100 milliseconds. Sender's TD. Receiver's TD, acknowledgement size is 100 bytes. Receiver transmission rate is 8 kbps. Again, that is in bytes, this is in bits. So 800 bits by 8 kbps, this also will be 100 milliseconds. And one way propagation delay is given 100 milliseconds. So this way 100, and for the acknowledgement to come back 100. So round trip time is 200. So what is the total time? T1 plus T2 plus P1 plus P2. So total is 400 milliseconds. In this much time, as per the stop and wait protocol, how many packets could be sent? Only one packet. So the throughput of the sender would be, one packet is sent in this 400 milliseconds time. So one packet means 1000 bytes in 400 milliseconds. But we want throughput in bytes per second. Per second. So this is 2500 bytes per second. Okay? Fine, next question. It's also a popular question. Consider a source computer transmitting a file of size 10 raised to 6 bits to destination computer D through routers R1 and R2. Let each link be of length 100 kilometers. Signal speed is given. Bandwidth is given. The file is broken down into 1000 packets of size 1000 bits. Find the total sum of TD and PD in transmitting the file. Yes. We have source, destination. In between there are two routers R1 and R2. Again the same concept. The total time would be, if there are n packets, for the first packet what is the complete time plus remaining packets what is the TD. So first let us calculate what is the transmission delay. File size, packet size is 1000 bits. Bandwidth is 1 Mbps. So this is 1 millisecond. What is propagation delay? Length by speed. Length is 100 kilometers. That means 100 into 10 cube meters. Speed is 10 raised to 8 meters per second. So this is again 1 millisecond. So what is the total time for one packet? T1, P1, T2, P2, T3, P3. So for time for one packet is T1 plus P1 plus T2 plus P2 plus T3 plus P3. That is 1 plus 1 plus 1 plus that is 6 milliseconds. Remaining how many packets are there? 1000 packets. Remaining total 1000. So remaining would be 999. So total time would be, first packet total time is 6, remaining packets 999. This is 1005 milliseconds. Next question. आ गया IP address, the share, the king of computer networks. The total number of hosts per subnet in the network with an IP address 132.123.112.57 by 24 is. Here /24, that means 24 bits represent net and subnet ID. That means 8 bits are there for host ID. So with 8 bits, total 2 raised to 8 addresses can be generated, but the first and last are reserved. Hence, the total number of hosts in each subnet would be 254. Right. So guys, till now we have solved 15 questions. So what is your score? Honestly. Don't say I joined late, I have just come. No. No excuses are allowed. Out of 15, how many you have given correct? Ruhi 10, okay. Nishat 14. Chandan 11, Muskan 11, Nishat 14, Kirti 8, Aditya 9, Madhav 13, Anvesh Patra 11, Sunil 7, De Villiers, Nishu, Unnati. Let's see. Maybe 30 questions or 25 to 30 questions minimum we will discuss. Okay. Sunil Kumar 7, Unnati 8, Anu 5. That's okay, that's okay. Great. So guys, I believe you are making a note. Like suppose Maheshwari, 2 questions are wrong for you. So did you made a note or not for those 2 questions? Why they are wrong? Is it a calculation mistake, or you don't understand the question, or lack of subject knowledge, or any silly mistake that you have done? Have you made a note? In that way, everybody, for your mistakes, please make a note. What is the reason that you could not give the correct answer for that question? So at the end, if you will see for 30-40 questions, at the end if you see what mistakes you are doing frequently, you will identify. If you see 4-5 calculation mistakes only, if you see lack of subject knowledge for 7-8 questions, that means you are lagging in the subject, like that. Okay. Next question. Break. So guys, it's not that we are telling being working in BYJU'S Exam Prep, but even as a student also, if I think, really at BYJU'S Exam Prep you will get quality and quantity both. You will get a good subject knowledge along with good number of questions for your practice, and majorly we can say we will try to 99.9% of the time the classes we try to keep in a proper structured plan. Okay, some 1% there could be some emergency, some due to some technical reason class could not happen, but 99% we go in a structured way, and the doubts resolution would be maximum at the earliest. So even as a student also, if I think, really it is a great platform where you can get subject knowledge and platform for practicing and to share your doubts with the faculty or co-students. You have our Telegram group. So we provide everything that you want. That's why we name BYJU'S Exam Prep as the complete solution for our gate problems. But of course, you also should accept, and I think there is no reason for not accepting, right? So do share and subscribe to our BYJU'S Exam Prep. Chalo, relaxed enough? Let's proceed to next question. Consider a class B network with IP address. The number of subnets and the number of hosts per subnet would be dash and dash respectively. नीरज भाई, नीरज क्यों? तो आपको मज़ा आने के लिए मैं क्या कर सकता हूँ? मज़ा नहीं आए तो भी परवाह नहीं, लेकिन आपको कुछ ना तो कुछ नॉलेज मिला, वो चाहिए, ठीक है? So what is the answer for this question? Consider a class B network with an IP address. The number of subnets and number of hosts per subnet would be okay. So here guys, /20 represents 32 minus 20 bits for host, and class B network, that means 16 bits would represent network ID. So remaining bits would represent subnet ID. So with 4 bits for subnet ID, actually 2 power 4 subnet IDs can be generated, but we know the first and last are reserved for broadcast, last one for the network interface, first one. So 14 subnets, and in each subnet 12 bits we have. In each subnet 2 raised to 12 minus 2, that is 4094 hosts per subnet. So 144094. Meenakshi, you are not understanding because you are not known to these concepts, or you have not solved these kind of questions ever. So if so, identify why you are not getting, when all the others are participating, giving the right answers, why you are unable to get. Next question. Intra-network and inter-network communications are carried out using dash and dash addresses respectively. Fine, fine, it could be some spam, leave it. They are just passing the time, wasting our time, leave it, leave it. Focus, guys. We are here to make you practice, to make you ready for the exam. So these sessions should help. So we are not here to entertain any unnecessary comments. If you are here to gain the knowledge, you can be here. Otherwise, please feel free to quit. Don't disturb others. Don't demotivate others, please. No noob studios, we do. Because like host is a child for subnet, subnet is a child for network. So we do -2. Intra-network means within the network, the communication is carried out by MAC address, and inter-network, between the networks, the communication is carried out by IP address, right? Just to see whether at least you people, some people might not be knowing it. Okay, this may not come in the GATE exam, but just I want you to excuse me, I want you to be sure of this. Next question. Consider 500 class A networks are organized into 10 groups of 50 networks each. The subnet mask used by the interface should be. Consider 500 class A networks are organized into 10 groups of 50 networks each. The subnet mask used by the interface should be. So we have 10 groups. That means subnet ID would require 4 bits, and it is a class A network. So network ID would be having 8 bits. That means host ID would be remaining whatever 20 bits. In the subnet mask, host bits would be 0, other bits would be 1, right? Host bits would be LSB bits. So 11111111 1111. 12 bits net subnet ID bits should be 1s, remaining should be 0. Right? So if you convert this into decimal, it is 255.240.0.0. Option A is correct. Whoever have given option A, please award a mark yourself. Next question. The subnet ID of given IP address is in binary. What is the subnet ID of this IP address? Use question number, dear students. Use question number. For which question you are giving the answer, please use it. (172). That means it's a class B, right? So class B means network ID 16 bits. Of course, with the options we can understand. That means subnet ID would be 20 minus 16, 4 bits. Okay. So 172, 148, this would be network ID bits. 152, 128, 24, right? This would be host ID. Right. So this is what subnet ID. 1001, 128, 16, 144, 8, 158. Yeah. So option B is correct for question number 19. Nishat, check yourself once. Okay. Next question. Even Sakshi, you are wrong. So please update your scorecard. The last host address of the network. Quick. Here, from the CIDR notation, /27 means 27 bits for net and subnet ID. That means 5 bits will be there for host ID. So in the given, keep 27 bits constant. 196, 140, 130, 24 and 110, 64, 32, 96, 8, 104, 108. This is 110, I believe. So this is what 27 bits. This would be same. Now these 5 bits will range from first to last. So the first address possible is 196.140.130.011 with all zeros. First address possible. So this would be 196.140.130.96. But first address is never allocated for the host. So when you say first host address, this would be 196.140.130.97. This is first host address. Similarly, what would be the last address that is possible? Means the broadcast address, you say 196.140.130.011 with other values. The last possibility for 5 bits is 5 ones. This is 196.140.130.127. Right? Now, this is the last address possible, but this is also not given for the host. So, the last host address would be 1 less than that, 196.140.130.126. Option C is the correct one. Pradhama, you are wrong. Anu, you are wrong. Sambhav Jain, you are wrong. Option C is correct. Okay. Next question. Which of the following is not a private IP address? This is again through this question I want to inform you that please have a look on private IP addresses, because there is possibility to frame a question around it. So, which is not a private IP address? Sambhav Jain says option D. Okay. What about others? See, this is what the private address range. Private address range is this. 10.0 to 10.255 means the starting is, the first octet is 10, so you can have any number after that. So definitely this is a private IP address. It is private IP address. Option D. No, it's not option D. 172.16, if it starts with, definitely that is private IP address, because later you can have any value. And up to 172.31 only, but you have till 64. So it is not private IP address. And 192.168, yes, after that you can have any value from 0 to 255. So it is also a private IP address. So which is not a private IP address? Option C. Many people have given option B, option D. At least with this question, you got to know. Please don't neglect, because may not be this question or this kind of question, but a question can be prepared around this private IP addresses. So please do go through this, or please keep this range also in your short notes. Okay? Next. The broadcast address of second subnet in a network with address 200.100.200.10/26 is. Quick. Okay, Muskan, you thought differently, but now you know what is the fact, no? That's enough. So remember. Question number 22. Kaushalya says C, Aarti says C, Sambhav Jain. Sambhav Jain, give only one answer. Only one. You are giving D, A, it's not MSQ. Piyush, option D. Anvesha Patra, option A. Rutvik, option B. Sakshi, option B. Okay. Sambhav, option A, you want to freeze. Okay. Chaliye. Let's see. /26 and 200. So it's a class C network basically. That means 24 bits represent net ID, and we have 26 means 2 bits represent subnet ID. So these 2 bits values would be 0001 1011, right? So 24 bits will not change, that would be network ID 200, 100, 200. So this will remain same. Now the next 2 bits for the second subnet. Second subnet means 01, and what we want? Broadcast address. Broadcast means the last possible host. So the remaining would be ones. So what is this value? Okay, sorry, I have taken extra 8 bits. So what is this value? 200.100.200.127. Okay. Next. So Sambhav Jain, Chandan whoever is giving other than B, please update your scorecard. Prakash, Noob Studios, Priyanka Garg. Okay. Next question. Noob Studios, what is that question? Why not A? Why A? It's a second subnet. So second subnet number would be 00011011. So 0001. And broadcast address we say. So it is yeah, it is again a popular question. Previous year gate question this is. Suppose a node with IP address hundreds, all hundreds, wants to send a packet to itself. Then the source and destination IP addresses would be source would be the same, but destination would be loop back address. When the destination address is a loop back address, then it's a self delivery. The packet would be delivered to itself. Okay, if you don't know, at least get to know that. Next question. If there are 64 frames to send, then n designates dash for sender window in GBN scheme. If there are 64 frames we have to send, then n designates what for the sender window in GBN scheme? Use the question number R3. For which question you are giving B? Okay. Guys, in go back n means sender window size. What is the sender window size in go back n scheme? 2 raised to small n minus 1 whole minus 1. What is the small n? Number of bits needed for addressing or sequencing. However, here n is small n is 6. Small n is 6. But what is capital N? 2 raised to 6 minus 1, 63. Guys, is it visible? Am I visible and audible to you clearly, or is there any lagging? Give me a moment. अच्छा सारे लैगिंग बफर में पहले एक बार स्टॉप कर लो wait guys, don't know whether you can hear this or not properly, it's lagging. Okay. म्यूट भी कर लो. I think it should be fine now. Please confirm my visibility and audibility. Yeah, Sunil, we have 64 frames. Let's say we are having n frames, then it should be log n. It should be log n. I think it should be fine now. Please confirm, guys. चलिए, let's proceed to next question. Suppose a sender A sends a message to receiver B in 200 milliseconds transmission delay and 100 milliseconds propagation delay, then The utilization of the channel under stop and wait scheme is, under stop and wait ARQ protocol, what is the utilization? Everybody give your answer for the question number 25. Option B, okay. Yeah. So utilization, you can say it is 1 by 1 plus 2a, where a is transmission delay by propagation delay. Now propagation delay is directly given, okay, both are given directly, so a would be 200 by 100 PD by TD, or no, it is propagation delay by transmission delay, right? Yeah, so propagation delay is 100 milliseconds, transmission delay is 200, so this is 1 by 2. If you substitute that here, 1 by 1 plus 2 into 1 by 2, so this is 1 by 2, that would be 50%. Okay. Next question. Consider the following specifications. The minimum number of bits for sequencing the frames is.